Welcome to the Crazy Hat Chemist. By the way, this is the 23rd video on stoichiometry and dimensional analysis totally. I want you to think about it. What is 1 mole equal to? Avogadro's number. And what is Avogadro's number? 6.022 times 10 to the what? 23rd. So why are there 23 videos? Avogadro's number, of course. So today is the 23rd video. It's 10.2. It's a limiting reagent problem in percent yield. It's as good as it gets, baby. So here we go. Bam! So you have 0.15 grams of propene reacts with 0.24 grams of oxygen. What mass in grams of gas is produced? If only 0.15 grams of gas is collected, what is the percent yield? And how much remains in excess? So I'm not going to give you as many steps here because we are really at the end of this unit of stoichiometry and you should know how to do all these problems. So I want you to pause the video. I want you to write the entire type of reaction of which this is, and I want you to balance it, write their stoichiometric coefficients, put their states of matter, and then bam, this is our answer. So there's our propene plus molecular oxygen. It's a combustion type of reaction. You always get carbon dioxide and water. And there we go. It's balanced for us. Okay? So you're going to balance the carbons first, then the hydrogens, and then the oxygens. At the end, you are using 9/2 in front of that molecular oxygen and then multiplying everything by 2. So what we have is the following. We have both reactants, that is, we have 0.15 grams of propene, that's a reactant, and we have 0.24 grams of oxygen, that's also a reactant. And it says, what is the mass in grams of gas produced? So what is the gas that is produced on the product side? That is this carbon dioxide. So I have to take both of the propene and the oxygen to carbon dioxide. So this is what I want you to do. I want you to pause the video again, and I want you to have 2 monorails. One of them starts with 0.15 grams of propene, which is C3H6. The other one starts with 0.24 grams of oxygen. And I want you to start both of those 2 monorails, and you are going to end up with grams of carbon dioxide. So pause the video, do that, and then here we go again. So I've taken my grams of propene using the molar mass of propene and converted it into moles of propene. Then using the mole ratio of 6:2 with carbon dioxide and propene to convert to moles of carbon dioxide. Then using the molar mass of carbon dioxide, converted it to grams of carbon dioxide. Hopefully that works. Then I'm going to do the same thing with the molecular oxygen, and that's 0.24 grams of molecular oxygen. Using the molar mass of molecular oxygen, convert that into moles of oxygen. Then the mole ratio of 6:9, that is moles of carbon dioxide to moles of oxygen, and then convert it to grams of carbon dioxide using the molar mass. This is the number I get for the top monorail. I need to round it to 2 significant figures, and that's that number, 0.47 grams of carbon dioxide. Then here is the second monorail in our calculator, and I'm rounding with the 0, so that's super simple, and I got 0.22 grams of carbon dioxide. Now what I'm going to do is I'm going to compare these 2 numbers, 0.47 and 0.22, which is the smaller of the 2. That is your answer. That is the maximum amount that is produced. So how much carbon dioxide is produced? 0.22 grams of carbon dioxide is produced. Now I need to answer which one is the limiting reagent. The limiting reagent is the one that produced the 0.22 grams of carbon dioxide, and that is the oxygen. What is the reactant in excess? That is the other reactant, which is the propene in this case. Okay, now I need to answer the next 2 questions. That is, how much remains in excess, and then what is the percent yield. So how I figure out what is in excess is I'm going to take the limiting reagent, that's the 0.24 grams of oxygen, and convert it to the other reactant, which is the propene. So that's what you're going to do. Pause the video, do that, see what you can come up with. So I'm going to first take the original amount that I have and then calculate how much I used. So the original amount, look at the problem in words, and you can see right there, that's the original amount of propene that I have. So how much propene did I use? I'm going to take the 0.24 grams of molecular oxygen and convert it into grams of propene. And that is this monorail. So it's the grams of molecular oxygen converted into moles of oxygen, using the mole ratio, converting it to moles of propene, and then the molar mass of propene. And now I have grams of propene that are used, or grams of propene that's required, which is the 0.070 grams of propene. That is how much is required. So make sure you understand this. If you have 0.24 grams of oxygen and 0.070 grams of propene, you will produce 0.22 grams of carbon dioxide. And the oxygen and propene, none of either of those will be remaining. It would be a perfect stoichiometric reaction. Okay? So, in order to figure out how much is left over of the propene, I'm going to take the original amount there that I had, minus the amount that is used, and now this is what I have in excess. So I have an excess amount of propene of 0.080 grams of propene in excess. All right. Now, I got one more question, and that's why this one is as good as it gets, because it's a limiting reagent, how much in excess, and a percent yield problem. So remember, a percent yield is the part divided by the total times 100, or the actual over the theoretical times 100. The given divided by the calculated times 100. Please look at limiting reagent number 2, or the percent yield problem that was prior to these two videos. Okay, so how much do I have of the carbon dioxide? There is the actual amount. So look at the words in that problem there, and it says 0.17 grams of gas was collected. So that is the given amount. That's going to go in the numerator of my term. Okay, and how much did I actually, that's the actual amount. How much is the theoretical amount? That is always calculated, and that is coming from the limiting reagent. So I'm going to take the actual amount, 0.17 grams of carbon dioxide, divided by the 0.22 grams of carbon dioxide. Notice the units are the same, the formula is the same. I'm going to divide them, multiply by 100, and this is my setup here. I have two significant figures here. I'm going to have two significant figures in this answer, and that's 77 grams of carbon dioxide. Notice that I have a number units formula for all of my stoichiometric parts. I have a number units formula for even the answers. Please do that. Okay, that was an awesome problem. And that was the 23rd video, because Avogadro's number, the mole, Avogadro's number of molecules in 1 mole is 6.022 times 10 to the 23rd. That's why there are 23 videos in this unit on stoichiometry and dimensional analysis. It doesn't get any better than that, does it?